Hello and welcome to the HSD Tutorial Series. This is Tutorial 5 on doing DCIR drop analysis. Kindly watch Tutorial 4 of the HSD series before continuing with this video. So in this tutorial video, we'll be focusing on performing DCIR drop using PIPro. PIPro in ADS has a very efficient net-driven PI analysis with 4 simulator engines, which offers you speed and accuracy, a completely net-driven use model. You could do decap value optimization, automatic schematic generation, etc. The role of PDN is to keep a constant per supply voltage on the pads of the chips from DC up to the bandwidth of the switching current. They carry the return currents for the signal line and avoid these overlaps. The latter can cause SSN problems. PDN has the largest size, carries the highest currents, including high frequency noise, and it has potential of causing radiated emissions. Now, why do we perform DC analysis? Well, a PI DC analysis computes the voltage, IR drop, current, and power loss density in VRM nets. It helps you to identify the IC and connector pins or stitching vias, drawing large amount of DC current at the nominal operating condition. Due to excessive voltage drops, power supply voltages and IC might fall below the recommended minimum voltage, which can lead to the failure of the board. In this tutorial, our objective is to learn how to set up a DCIR drop simulation in PIPro, how to set up VRM and sinks, and then look at the results. For this case, we will be using the VBAT power net, and this slide shows you the VRM detail and the 5 sinks which we'll be using for our simulation purposes. So let's get started and have a look at how you can perform a different sequence of operation to perform a successful DCIR drop. Now for this demo, we will use the old Panda board which we imported during tutorial 4, and we will set up a new SI and PIPro setup to perform all the power integrity analysis. So you can go to Tools, SI Pro, PIPro, and create a new setup. Give the setup your desired name. So in this case, I'm just calling it PI analysis. Click OK, and now you will have a new analyzer window with a default setup. So we can go ahead and delete all the unnecessary analysis which we have to keep our view clean, and we will rename our DC analysis name as VBAT DCIR drop. Right now we can expand and see the required things to be added in order to perform simulation. Now we have the whole design database as we discussed in tutorial 4. So we have all various components, all the nets which we can use for our analysis purpose. So before we get started, we will change the conductor to wireframe mode and switch off the component view. Now under the nets, we can filter out our desired net. In this case, it's VBAT. We can select the VBAT and drag and drop it under the nets in analysis portion. Before doing that, we can also observe which net we are trying to simulate once it gets highlighted. Once VBAT is already placed, we can select ground net and add it in the list. Now once we have both the nets, we can simply right click to the VBAT and we can select what instances are connected to this particular net, and we can see all the components which are connected to this net is highlighted. We can scroll through and find our VRM or sink as may be required. So first we will look at VRM, which is identified as R186. We can drag and drop it to the VRM, and then when prompted, select VBAT net, because it might be possible for a component to be connected to multiple planes or nets. Now notice the warning sign complaining about minus pin, so we can simply right click and select add nearby pins to minus terminal. So PIPro will try to find the nearest possible negative pin for the plus pin which we have added on VBAT. If you require, you can also manually filter out the component which you want to use as a negative pin. Now let's filter our desired sinks from the component list. So we have 5 sinks which we will use, starting with U11, and then we again select VBAT as the net which we want to analyze or which this component is connected to. Similarly, we can repeat the same process for all the other sinks. In PIPro, it is also possible to select multiple sinks or components with a filter command, but in this case, for sake of simplicity, I'm only showing one by one selection. We can also right click. If drag and drop doesn't make sense for you, you can also right click and select create sinks for analysis. In case there are multiple analysis in the list, it will give you choice of selecting the right analysis in which you want to add this component for sync or for VRM purpose, as you might be doing. Right now we only have one sync, hence there is no option given to us. It simply adds it into the analysis which is available. Now we have all the 5 syncs in place. We have our VRM. We can go to next step and specify their respective properties. So double click on the VRM and then set the property which is 3.5 volts as per the data sheet. Voltage tolerance to be 1%. Inductance and resistance do not make sense too much in DCIR drop. We may use it when we do the PDN analysis. Now the sync properties can be individually set by double clicking on it, or we can right click on syncs and say all properties. This will give us a table where we can enter the properties of each of the sync we have. Now as per the data sheet, we will start specifying the current characteristics of these individual ICs, with U11 being the highest current consuming IC in our case, which is 1.6 ampere. You could also set the desired resistance and voltage tolerances, etc. Also for the pin current model, there are 2 modes available in PIPro: equal voltage and equal current, and you can select based on the desired requirement. Now with the VRM and sync specified, we are all set to start simulation. Just before starting simulation, you can double click on options and see the default mode of use resistive losses in ground is selected. That means we will take into account for all the losses which is contributed by our return path or the ground plane. Simulation takes a few seconds to finish, again depending upon how large is the power plane, how many number of layers you have, and what is your PC processing power. In this case, it takes around 30 seconds or so to finish the simulation on my laptop. And once the simulation finishes, we will have results in different formats for us to see. Now the simulation finishes. It takes, as I said, around 30 seconds or so to finish on my machine. Now we can go ahead and expand the results available, and then we can have a look at different things in the results. So we'll start with current density. So double click on the current density plot, and it shows us the total current distribution in our board. So we are only interested to see the current in power plane. So we'll select net type as power and hide all the other conductors so that we can only see the power plane which we have analyzed. After zooming in, you can see the current density with a shaded plot as well as the current vector showing the direction of the current flow. This view helps you quite a lot in case we have to find a current crowding area where current might be getting up into a pretty high density. Also, we can see the vias and how the current is distributed in the via. We can use the field reader tool, and we can hover the mouse after clicking on field reader tool, and as you notice on the top bar, we have the current density being displayed depending upon where we are placing the our mouse cursor. You can also see the current distribution in the via, and as you can see, it's not uniform. The current density changes in the via depending on which location we are probing. Once we are satisfied, we can go ahead and unload this result, and then we can plot some other things. So in next case, we can double click on voltage and repeat the same way. We will only switch on the power net and then inspect how is the voltage distributed across our plane. If needed, we can also use the field reader tool to read out the voltage. Now we will unload the voltage as well, and now we can double click on overview and look at the various results which are available in the overview. Starting with power graph, which shows you the VRM and the sink. Also notice it for every sink, it denotes the total voltage loss and also the individual loss. That means the loss contribution due to the power plane and the ground plane. Observe the other tabs. We can see the report for each sink in terms of IR drop, resistance seen by that sink, IR drop and total IR drop, as well as power and ground plane IR drop. You can look at the VRM performance criteria. You can also look at layer wise in terms of minimum and maximum current density, maximum and minimum voltages, and we can also observe the results per pin. We can see all the pins and the required voltage and current. Under VRs tab, we can also see how much current is being passed through VR. We can set up a maximum current threshold condition and find the violating VR, which may be drawing more than the specified current. So in this case, we have one violating VR. By selecting on that and pushing this window aside, we can see the VR is highlighted with the current. Temperature, if you notice in all these cases, is 25 degrees centigrade because that's a nominal temperature which we have used in simulation. It's also possible to export this results as HTML or as a doc file report. So in this case, I will demo how to generate an HTML report file, which will contain all the results which we have obtained in a user-friendly shareable format, which can be shared within internal teams, also to external customers if we have to give them the total analysis overview. By clicking on this, and we can see the report opens containing all the key results which we have analyzed in a very nice user-friendly format. So hopefully this gives you an idea how to set up VRM, sync, how to run a DC IR drop analysis using PIPro, and also how to observe the results. So this concludes this tutorial video. Stay tuned for next tutorial video, that is video 6 on PDN impedance analysis using PIPro. Hope it was of your help. Stay tuned for more videos and subscribe to my channel for more such tutorial videos. Thanks a lot for watching.